everyone. My name is Mustafa, and today I'll be giving a brief session about Crossplane and how it allows you to provision and manage cloud infrastructure. Uh, Before I start, I would like to appreciate the KCD team for organizing this event and thank them for the opportunity to talk about Crossplane. A little bit about me. I did my bachelor's degree from FAST Islamabad, and I started off as a data engineer at CM Park Song, and then I transitioned to a platform and DevOps engineering role, and I have been working for around 2 to 3 years, primarily focusing on OpenShift and Kubernetes. I currently work at Stakeator, and we have been building products and providing services in the cloud native ecosystem for around 8 years. We have a lots of open source contributions as well, and the most popular one among them is Reloader. So yeah, let's get started. So what exactly is Crossplane? So Crossplane is a framework for building cloud native control planes. So in simpler terms, what it means is that Crossplane allows you to manage configuration in remote system using Kubernetes custom resources, and all the public clouds such as AWS, Azure, GCP, Alibaba are supported, and the ecosystem is increasing. And in addition to that, you can also enable self-service by writing custom or high-level APIs and combine resources from different providers and offer them to your end users so that they can easily consume or get the infrastructure that they need. So basically, this is a project by a company called Upbound, and it's a very big open source project with lots of community around the world. So let's talk about the basics. Consider AWS. It has it offers a lot of different services that relate to storage, compute, networking, databases, and identity management. So Crossplane allows you to manage these services by simply creating Kubernetes resources with the required configuration. And what this means is, consider the image on the left. So this is a Kubernetes resource with the kind bucket. So when you apply this resource to the cluster, Crossplane will create this create an S3 bucket in the AWS account that you have configured. And a bucket is just a simple example. It could be a container in Azure Blob Storage, or it could be a BigQuery table in GCP. So you can create any resource in any cloud, and this bucket resource, on the screen you can see that this bucket resource has a spec that tells us the desired state of this resource. And on the image on the right, you can see that the region of this bucket is US West 1, and there's a tag present as well. So, and this is the same that we have specified on our manifest in the left side. And these low-level resources are called managed resources. And like any other Kubernetes resources, this resource also has status. We can get conditions, we can get conditions and events about the resource. And one important field in the status object in the status is the add provider object. And what this so basically, Crossplane writes the information that it receives from AWS about the bucket in this field. So on the screen you can see that we have the regional the ARN, the regional domain name, the hosted zone ID in the status of this bucket, and other info as well. And similarly, we have events as well that tell us whether the resource was created successfully, and it also describes if there were any errors so that we could fix them. And this is how the implementation looks like. You can create a YAML representing a resource on your cluster, on your Kubernetes cluster, using either kubectl or a GitOps tool such as Argo CD or Flux. And there would be a AWS controller running in the that would get the event about the creation of this bucket, about the creation of a resource. In this case, it's a bucket. And then this controller actually talks to the AWS API to create it. And the same is the process for update, and delete as well. When you delete the resource, the AWS controller will respond and delete the resource in AWS as well. And so how does this bucket resource actually become available on the cluster? So the answer is providers. So similar to how we have providers in Terraform, we have providers in Crossplane that allows it to manage configuration in cloud and cloud SaaS and other external systems. And there are providers available for all the public clouds, GCP, Azure, AWS, Alibaba as well. They basically, providers translate your Kubernetes resources in external API calls. And so basically you can go through a list of all the available providers at the Upbound marketplace. And so creating so you can create a provider by simply creating a simple manifest on the cluster. When you install Crossplane, a provider custom resource becomes available to the cluster, and you can simply create an object of this resource on the cluster. So this current manifest deploys the AWS S3 provider, and when you deploy this provider, it will add custom resources, CRDs, to the cluster that will allow you to manage S3 configurations using custom resources. And we can see that a controller is added as well in the list of pods. So basically this pod will actually reconcile your resources in external systems. And at the top, the resources that you are seeing, these resources are basically what's called managed resources or granular resources. So and this is just a small list for now. There are a lot more configurations that you can manage. So the next step is, how can you build your platform? And so installing a provider, we saw that installing a provider adds a list of granular resources to the cluster. But these granular resources cannot be consumed as they are. We need a high-level API or a custom API and offer them to our end users to hide the complexity of the infrastructure, so that our users could have, the end users could have an easy way of consuming and getting infrastructure. Let's consider this diagram. On the right side, you can see that we have managed resources, and these managed resources are brought into the cluster by providers, and you can combine these, you can offer them to your users as a custom API. First, you will combine these resources using a composition, and then you can give them to your users or offer them to your users as a custom API by defining a composite resource definition, or it's also called an XRD. And on the right side, you will have your users or the application teams, and they can simply create infrastructure by they can get the infrastructure that they want by simply creating a Kubernetes resource, which is called either a claim or a composite resource. So the team says, so let's say we have a team that says they need an EKS cluster. So what we do is we define a composite resource definition that allows us, that enables a new API in the cluster. And for this composite resource definition, or XRD, we define a composition in which we will tell Crossplane which managed resources it should create whenever an EKS cluster object is created. This could mean it has to create a VPC, security groups, IAM roles, node groups, a load balancer, and the cluster, EKS cluster itself. So it can create all of these resources will then be created by Crossplane. So to define your custom API, you create a composite resource definition, or XRD. You define a name, you define a group. You can use a group to organize your custom APIs. And then we can define the schema as well. So the schema would be just the shape of our custom API, and we can also define parameters that we want to customize or take as input. And so in this example, we have an EKS cluster composite resource definition, and the schema simply defines a worker node count that we'll take as input from our users. So when we create this composite resource definition resource on the cluster, our users will be able to create an EKS cluster resource on the cluster, and they can create a resource of this kind. So this will now our users can simply create this resource and get an EKS cluster simply. On the screen, so basically this resource is actually called a composite resource, and at the bottom you see a similar resource, but this is the namespaced version of the same resource that you see at the top. So this enables self-service for our end users. But so we need right now, when we create this resource, nothing will happen. We need a way for Crossplane to know which managed resources it needs to create whenever this EKS cluster or a new custom API object is created. And we do this by defining a composition. So what you do is you add all the managed resources that you want to create from one or more providers into the composition, and then reference a composite resource definition inside the composition resource. So what will happen is whenever you create your new custom API, Crossplane will create all the managed resources that you have specified in spec.resources. And it will create all of these resources, all of these managed resources, and Crossplane will keep on reconciling them until they become successful or available. And it has a way of becoming eventually it's eventually consistent. So so basically let's discuss about a few problems with composition. So or an issue is problems is so basically you cannot use compositions to handle advanced logics, so basically you cannot write loops, conditionals, or any other logic to decide which managed resources you want to create. And the list of resources that we define is static. It's not dynamic, and we cannot decide based on any logic which resources we need to create. And the amount of transformations on inputs is very limited. So Crossplane functions help us in solving these issues. So instead of manually defining resources and compositions, we can ask a function to tell us which managed resources need to be created whenever our new custom API object is created. And we can create a function in a language of our choice as well, and you can add advanced logic according to your needs to determine which managed resources need to be generated or created. And you can there are community written providers as well that you can use. So basically the function runs as a pod along with the Crossplane deployment. So let's talk about extending Crossplane. You can create providers and teach Crossplane how to manage new systems. And as long as there's an API, you can write a provider for it. Then once you have built your custom APIs, you can package and distribute them. And a collection of your custom APIs is called configurations. And you can share them with the community as well. And then what you can do is you can also write functions or create composition functions that use advanced logic to determine which resources it should create for a composition, and then package and share them with the community. So that's about it. There's a little demo as well, but before we do that, on the screen you can see the Upbound marketplace. So basically this Over here you can find all the packages related to Crossplane. Over here you can see you have providers, you can have configurations which are just your custom APIs, and then we have functions as well. So let's say I want to manage S3 buckets. So I'll simply find the AWS S3 provider and go to its home page, and on its home page you can see there's general information about the provider, and you can see there's the source code link, and you can see that it tells us about all the managed resources or all the configuration that you can manage by installing this provider. You can see that we have a bucket notification resource, we have a bucket object resource, a simple bucket resource as well, and we can click on these resources to actually see which fields we can define. So yeah, on the home page of the provider, you'll be able to see this install manifest button, and so basically you can see on the screen that the manifest that we can use to deploy this provider or add this provider in the cluster is presented to you, and you can just copy it and apply it to the cluster. So yeah, let's start with the demo. So I have Minikube running locally. Let's check if it's running. Yeah. So basically the first step, I already have this S3 provider in a file locally. So the first step is to create a provider and on the cluster. So basically this will add a bunch of managed resources that we can use to manage configuration in our target system. In this case it's S3. So yeah, it's created. Let's get the providers and see. So we have our AWS S3 provider over here. Currently it's installed, but it's not healthy, so we'll wait for it. So you can see that we have, meanwhile we can see that we have other providers available as well, DynamoDB and EC2. So let's see which resources we can manage using this EC2 provider. So I can see that by simply getting the CRDs that are available in the cluster. So yeah, over here you can see that we can create transit gateways, we can create subnets, we can create security groups, we can create routes. So adding this provider, using these resources, we can manage all aspects of the EC2 service. And by now our S3 provider would be ready as well. Okay, so it's ready. So let's get the list of CRDs and see which resources we can create with this provider. So yeah, you can see that we can create buckets, we can create bucket notifications, bucket metrics, and a whole lot of other resources as well. So yeah, and in the Crossplane namespace, there will be pods that run the controller for this for these resources. So yeah, we have in provider S3 pod as well. So the first step is we install the provider. The next step is to install provider config, and inside the provider config, we define parameters with how Crossplane should talk to our external system, which is AWS. And this is just a simple field. Currently I have defined a secret reference that contains the credentials for our AWS account. So I'll simply just apply this to the cluster and wait for it to be created. Okay, yeah, it's created. And then now I can create my bucket resource. So let's see what it is, what the manifest or YAML is. So yeah, we have the name of the bucket. We have defined the region and the tags in AWS as well. So before I create this bucket, I'll show you the buckets currently present in my AWS account. So you can see currently there are no buckets present. So let's get back and create a bucket. Okay, so the bucket has been created. Let's see if it's present on the cluster. Yeah, it's present. It's synced, but it's not ready, which means the bucket wouldn't be created. Let's describe this resource and see what the events are. Sorry about that. Yeah, sorry about that. Okay, let's describe this bucket and see. So over here you can see we have the spec of the bucket, the status, and we have the events as well. So it says that the bucket is created. Let's go to the AWS console and see if the bucket is created. So yeah, great. We have our bucket. So you can see that the region is US West 1, and we have our tag present as well that we defined. So yeah, and yeah, that's and if I show you, so if I describe this bucket, you can see that inside the status field I have all the information returned from AWS about this bucket. So we have the ARN, the regional domain name, and other info as well. So yeah, that's it for the demo. Hope you enjoyed it, and yeah, wait, let me get back to the slides. So yeah, so this was a brief session about Crossplane. It's a very powerful tool that you can use to manage your cloud configuration, and I'd encourage you to explore it. Thank you for listening and hope you enjoyed. You can also connect with me on LinkedIn as well. Thank you. Bye bye.